In 12.1, we're going to look at congruence and similarity. In the first figure, notice that the birds and the fish are exactly the same size and shape in this pattern. Congruent fish and congruent birds have the same shape and same size. In the second figure, notice there are 4 small triangles, and each of these small triangles are congruent. They have the same side lengths for each of these small triangles, so they're all congruent. They have the same side lengths. And the angles for each of the triangles are also the same. In this case, since they're equilateral triangles, each of the angles is 60 degrees. So all of the angles are 60 degrees, and therefore these triangles are congruent. If you compare the smaller triangle with the bigger triangle, you'll notice that they have the same shape. It's twice as long as the smaller triangle, but they aren't exactly the same size. Similar triangles have the same shape, but not the same size. They could be smaller or larger or equal. Similar objects, we use this symbol, this wavy symbol, to describe an object that's similar. It has to have the same shape, but not necessarily the same size. Congruent objects, we use this symbol in which the wavy sign is on top of an equal symbol. It has to have exactly the same shape and same size. Congruent objects are similar, but similar objects are not necessarily congruent. Remember, in order to be congruent, you have to have the same shape and same size. So if you are congruent, you're automatically similar. To be similar, you just have to have the same shape. So similar objects aren't necessarily congruent. The first triangle, we'll call it triangle ABC. The second triangle, I'm going to call that triangle A prime, B prime, C prime. Now, when I say that these two triangles are congruent, I have to make it so that the corresponding parts match with each other. Notice angle A is equivalent to angle A prime. Angle B is equivalent to angle B prime, and angle C is equivalent to C prime. So you have to write it in this order. You have to write triangle ABC is congruent to triangle A prime, B prime, C prime in that order. Triangle ABC is congruent to triangle A prime, B prime, C prime, written as triangle ABC congruent to triangle A prime, B prime, C prime, if and only if angle A is congruent to angle A prime, angle B is congruent to angle B prime, angle C is congruent to angle C prime, and segment AB is congruent to segment AB prime, segment BC is congruent to segment B prime C prime, and segment AC is congruent to A prime C prime. Corresponding parts of congruent triangles are congruent. We abbreviate this with CPCTC. Example. Let's write the appropriate symbolic congruence for each of the pairs. In example A and B, we're given that these two triangles have congruence. They are exactly the same size and shape, but their orientation is different from each other. So we'll have to write the congruence symbol with the letters in the correct positions. We'll call the first triangle ABC. Triangle ABC is congruent to triangle. Now we have to be careful that we write it so that the corresponding angles are equivalent. So if you look at angle A is opposite the number 4. So the angle that corresponds to angle A must have an angle opposite to the side length of 4. So that's going to be angle E. So we have triangle E, and then we'll have to look at the other angle. Angle B has 3 opposite of it. So the 3 is opposite angle F. So the next angle must be angle F. And then finally D. So triangle ABC is congruent now to triangle EFD. Notice that angle A is equivalent to angle E, angle F is equivalent to angle B, and finally angle C, which is 90 degrees, is equivalent to angle D. I know in a triangle the angle sum, or the interior angle sum, must add up to 180 degrees. Since this is 60 degrees and this is 90 degrees, this has to be 30 degrees in order for the interior angle sum to be 180 degrees. And similarly here, this must be 60 degrees in order to add up to 180 degrees. Now triangle ABC is congruent to triangle. I have to start with one of the angles here. We'll start with 60 degrees, and that has to correspond to R because that has an angle that's equal to 60 degrees. So we say R, and then the next angle is angle B. That's 30 degrees, and that must correspond to Q. So it's triangle RQP, since P is 90 degrees and C is also 90 degrees. So triangle ABC is congruent to triangle RQP. If the three sides of one triangle are congruent, respectively, to the three sides of a second triangle, then the triangles are congruent. This is saying if I have a triangle and another triangle, this side is congruent to this side is congruent to this side, and the third side is congruent to this side, then these triangles, let's give them names. Triangle ABC must be congruent to triangle DEF. The reason for this is the sides are all equivalent to corresponding sides, and since that's the case, angle A must be equivalent to angle D, angle B must be equivalent to angle E, and finally angle C must be equivalent to angle F. Use side, side, side to explain why the given triangles are congruent. So we're given that these two triangles are congruent, we just have to explain why. Notice that segment AB is congruent to segment DE. So I can say that AB is congruent to segment DE, and segment BC is congruent to segment DF. And finally, segment AC is congruent to segment EF. Segment AC is congruent to segment DF. Since the corresponding sides are all congruent, we have side, side, side. And therefore, triangle ABC must be congruent to the other triangle. Now, I need to make sure it's in the correct order. So angle A is opposite of 2, angle B is opposite 4, and angle C is opposite 3. So we'll have to write this triangle in the correct order. Triangle E, because that's opposite of 2, then F, then D. So triangle ABC is congruent to triangle EFD. In the second pair of triangles, we have that they share a common side, so we know this common side is the same. Segment AB is congruent to segment BD. And clearly segment BC is congruent to itself, segment BC, because it's the same segment. And finally we have segment AC is congruent to segment CD. So we have the side congruence theorem, and therefore triangle ABC is congruent to triangle. Triangle ABC is congruent to triangle DBC. Let's check our work to make sure we did it right. ABC starts with the segment AB with the length of 8, the shared side, and then 5. Triangle DBC starts with the side length of 8, the shared side, then 5. So yes, we did it right. Triangle ABC must be congruent to triangle DBC. The sum of measures of any two sides of a triangle must be greater than the measure of the third side. The sum of the measures of any two sides of a triangle must be greater than the measure of the third side. What that means is, if I take a triangle with the side lengths A, B, C, I can take any pair of sides and add them together. That must be greater than the third side. So A plus B must be greater than side C, or A plus C must be greater than side B, or B plus C must be greater than side A. Let's look at an example. Determine if it is possible to draw a triangle with the side measures 12, 11, and 17. We'll check that the two sides, if I add them up, must be greater than the third side for any two sides. 12 plus 11 is greater than 17, yes. 11 plus 17 is greater than 12, yes. 12 plus 17 is greater than 11, yes. So it is possible to have a triangle with the side lengths 12, 11, and 17. But let's look at another example, 2, 5, and 12. If I take a potential triangle with the sides 2, 5, and 12, I'll check and add 2 plus 5. 2 plus 5 gives us 7, and that is not greater than 12. So you can't have a triangle that has side lengths 2, 5, and 12. It's not possible, because 7 is less than 12. Side angle side congruence, or SAS. If two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle respectively, then the two triangles are congruent. What does it mean to be an included angle? The included angle is essentially formed by the two sides, S, and the other side, S. Use side angle side to show that the given pairs of triangles are congruent. Notice that segment BC is congruent to segment DF. Also notice that segment AB is congruent to segment DE. The angle is also equivalent. The measure of angle B is congruent to the measure of angle D. Notice that angle B is included to the side AB and the side BC. Similarly, angle D is the included angle of DF and DE. Therefore, triangle ABC must be congruent to triangle EDF. For the next triangle, we need to show that these are congruent with side angle side. Notice that the segment DB is shared, so this segment implies that DB is congruent to itself, segment DB. Segment AB is congruent to segment DC. We're given that segment AB is parallel to segment DC. AB is parallel to DC, and we have a transversal DB. Therefore, this angle must be equivalent to this angle, and this angle must be equivalent to this angle since they're alternate interior angles. So the measure of angle CDB is congruent to the measure of angle ABD. Therefore, triangle ABD is congruent to triangle CDB. The hypotenuse-leg theorem. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. Since the triangles are a right triangle, we know that they must have a 90-degree for one of the angles. And according to the Pythagorean theorem, a squared plus b squared equals c squared, since they share a leg of the same length and the hypotenuse of the same length, you can prove that the third side must also be the same length. So this theorem is a consequence of side, 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 and therefore these two triangles are congruent.